Chapter Review 4, question number 1. On the same axis, sketch the graph of y is equal to x squared into x minus 2 and y is equal to 2x minus x squared. So the first one here is a cubic curve and the second one is a quadratic curve with a negative x squared, so it's going to be inverted. So let's start by sketching the curves. The first question and the first curve is the cubic one, which is y is equal to x squared into x minus 2. Second one is y is equal to 2x minus x squared. Now, before we sketch the curve, we need to know that when we sketch the curves, we need to find their x-intercept and y-intercept. In order to find the x-intercept, we equate y to 0, and in order to find the y-intercept, we equate x to 0. So let's find the x-intercept by equating y to 0 for the cubic curve. So 0 is equal to x squared into x minus 2. Therefore, x is equal to 0, x is equal to 0, and x minus 2 is equal to 0. So we have x is equal to 2. So we have 3 x-intercepts. One is a repeated root. So on a repeated root for a cubic curve, the curve touches this root and it bounces back from here. So that was the x-intercept for the cubic curve. Let's find the y-intercept. So for the y-intercept, we equate x to 0. So if we equate x to 0, we have 0 squared into 0 minus 2, which is 0 into 0, which is 0. So the y-intercept is 0, 0. It passes through 0, 0. Next, moving on to the quadratic curve, we have y is equal to 2x minus x squared. In order to find the x-intercept, we equate y to 0. Factorizing, we have x into 2 minus x. Therefore, x is equal to 0, or 2 minus x is equal to 0. X is equal to 0 is one of the roots. 2 is equal to x, or x is equal to 2 is the other root. So let's start by sketching. Okay, now for the quadratic one, we can also find its y-intercept. So we can equate the x to 0. So when we equate x to 0, this is 2 into 0 minus 0 squared. So this also passes through 0, 0. So its y-intercept is also 0, 0. So let's start by drawing our axes. This is our x-axis and this is our y-axis. So we'll start by sketching the quadratic curve. This is our origin 0, 0, and say for example this is 2. Both the curves pass through 2. Since the quadratic curve has a negative coefficient for x squared, it's going to be inverted. So this is the way it's going to look. So that is our quadratic curve, which is y is equal to 2x minus x squared. Now let's move on to our cubic curve. Y is equal to x squared into x minus 2. We have 0. The graph is passing through 0 and 2. Now, in order to find the direction of the cubic curve, we can plug in any positive value for x. Say easiest positive x value is 10. So we need to find when x is positive, y is positive or negative. So we know where does the curve start. So if x is 10, so this is 10 square into 10 minus 2, that is 100 into 8, which is a positive y value. So for the cubic curve, when x is positive, y is also positive. So the curve starts from first quadrant. So starting from the first quadrant, it passes through 2 and then it bounces on 0. So starting from, let's take another color. So starting from the positive or the first quadrant, passing through 2, passing through 0. Now, Here a very important point. A cubic curve is always steeper than the quadratic curve, and it crosses or it cuts the quadratic curve. So as we see, the cubic curve is cutting the quadratic curve, because it was also possible that the cubic curve would run along the quadratic curve like this. But when the cubic curve comes, it cuts the quadratic curve because cubic curve is steeper. So they intersect here at a point. Now that was the answer to part A. This is the graph of y is equal to x squared into x minus 2. Moving on to part B, it says by solving a suitable equation, find the points of intersection of the two graphs. So we need to find the point of intersection. I'll just reduce the size so I have space. So when we want to find the point of intersection of the two curves, we equate the two curves, or we equate the y values. So here we have y is equal to x squared into x minus 2 and y is equal to 2x minus x squared. We equate the two y values and solve them simultaneously. So we have x squared into x minus 2 is equal to 2x minus x squared. So we can open the bracket here. We have x cubed minus 2x squared plus x squared minus 2x is equal to 0. So we got everything on one side. We have x cubed minus x squared minus 2x is equal to 0. Now we can factorize by removing x common out. We have x squared minus x minus 2. So we have a quadratic expression here. The product is 2, negative 2. Sum is negative 1, coefficient of x. So the numbers that multiply to give 2 are 2 1s are 2 and add up to negative 1. So minus 2 plus 1. So this should be x into x minus 2 into x plus 1 is equal to 0. So therefore our roots are x is equal to 0, x minus 2 is equal to 0, x plus 1 is equal to 0, and hence the roots are x is equal to 0 is the first one, x is equal to 2, and x is equal to minus 1. So x is equal to 0 is one root, which is where both the curves are intersecting. So both the curves are intersecting at x is equal to 0. Second place where both the curves are intersecting is x is equal to 2. And the third part where both the curves are intersecting is this point where the x coordinate is negative 1. So let's write the three coordinates of intersection. So one is 0, 0. Second is 2, 0. And the third one, we have the x coordinate of the third point, which is this one. So the x coordinate is negative 1. We can find its y coordinate by plugging in x is equal to negative 1 into this equation, or we can do it in this equation also. So 2 into negative 1. So if I plug in negative 1 to find the y value, I have 2 into minus 1, minus 2 minus the minus 1 squared, that is negative 3. So we get the y coordinate as minus 1 is the x coordinate, negative 3. And that answers the first question from chapter review.